Alright, hello everybody. So, it is currently 4 o'clock in the morning, and I figured it'd be a perfect time to do some math. So, what I'm going to do right now is I'm going to show you guys how to derive the quadratic formula from completing the square. So, we've already done completing the square. Quadratic formula is basically another way of solving those without having to complete the square. This becomes more useful when things become harder to factor. So this is actually going to be one of the more useful formulas that you learn in math going forward. You're going to need to use it a lot. In fact, it's going to be one of those formulas that you should probably memorize. Okay? I don't usually say you need to memorize too many formulas, but going forward in math, this is probably one that you need to memorize. But let's figure out how we would get this formula from the process of completing the square. So first of all, when we have a quadratic equation, it's usually set up like it should be set up like this, right? This is what a quadratic looks like. You'd have some number times x squared, and then plus some number times x, and then plus just some number, and that should be equal to 0. Okay? For the quadratic formula, or for most quadratics, we want to get these three numbers, or three terms all by themselves and have it equal to 0 before we start. We didn't necessarily have to do that with completing the square, but with the quadratic formula and stuff, we need to get these three terms all isolated by themselves over here. And so one thing you didn't have to worry about with completing the square, because we didn't have you worry about it, is the coefficient in front of the x squared. With completing the square unit, we always had that as 1, because it has to be 1 in order to complete the square. Obviously, that is not always going to be the case. So if I were to solve this using completing the square, so without even knowing what any of these numbers are, the first thing I would do is I'd have to get that first term to a coefficient of 1. So to do that, I would have to divide it by a to get rid of it, right? But if I divide that by a, I have to divide every single term in the equation by a. So the first thing I'm going to do is I'm going to divide, my pen works, everything by a, because I want to get that to a coefficient of 1 to start with. Now the a's would cancel out here, and I'd be left with x squared. Okay? But then I still have bx all over a, and then plus c all over a, and then 0 divided by a would still just be 0, right? Okay. Now, in order to complete the square, I have to take the term in front of the x, that second term, and I have to divide it by 2, right? So right now, that's b over a. So I would take b over a and divide that by, well, I don't know what I'm trying to say here. Divide that by 2. So divide by 2, right? When I divide something that's already a fraction by 2, it's like multiplying the denominator by 2. So that would equal b over 2a, right? That's dividing that by 2. And then in order to complete the square, I have to take that term and I have to square it, right? When I square that, I would get b squared over 4a squared. Okay? So then I'm going to plug this into my equation to get that, complete the square term here. So I would get x squared plus bx over a, and then plus b squared over 4a squared. And then I'd put those in parentheses, right? That's what I'm going to factor. But then since I added that, I also have to subtract b squared over 4a squared. And then I still have this plus c over a. Now, this is going to factor down to the number that I squared, right? It'd be plus, because that's the sign of the number in front here, be plus this number. So I could factor this, everything in parentheses here, down to x plus b over 2a. squared. But then I've still got all these terms, and that was equal to 0 still, right? So I've got these terms in front here, negative b squared over 4a squared, and then plus ca over a, okay, is equal to 0. So what I'm going to do is I can't combine them because they don't have the same denominator. I am going to do that, but first thing I'm going to do is I'm going to move these over to the other side. Okay, so I'm just going to add b squared over 4a squared, and then I'm going to subtract ca, or not, I don't know why I put an a there, c over a, and I'm going to do that to both sides. And then minus c over a. And that's going to give me x plus b over 2a squared is equal to b squared over 4a squared minus ca. So now let's try and get these to the same denominator so that we can combine them. So in order to get these to the same denominator, this is 4a squared, this is just a, right? So that means I have to multiply the top and bottom by 4 as well as an a in order to get that to 4a squared. So that means on this term, I'm going to multiply this by 4a to both the top and the bottom, right? Which is going to give me 4 times c times, or 4a times c, right? So I would have b squared minus 4a times c, and then I'd have over 4a squared and over 4a squared. Okay? Now they have the same denominator, I can combine them. So I can combine them to become b squared minus 4ac all over 4a squared. And that's equal to x plus b over 2a squared. Pen is not cooperating. Now, this is where I can undo this square, right, by square rooting. I'm going to square root both sides. So I square root both sides, that gives me x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac. And then can I square root 4a squared? Does that go evenly? It does, right? What does it become? Square root of 4 is 2. Square root of a squared is a. So I can rewrite the bottom as just 2a. Now, to get the x by itself, I would minus b over 2a to each side, right? Minus b over 2a. And when I rewrite that, I'd have x is equal to, do these have the same denominator? They do, right? So I can write everything under or over 2a. It would be negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, my friends, is the quadratic formula. Okay? So essentially, by completing the square, you guys are doing all of this stuff. It just looks a lot more complicated here because I left it as variables instead of combining things and stuff like that. But this is the process you guys have been doing when you have been solving these equations. This is just putting it together in a nice handy-dandy formula that also makes it a lot easier to be able to solve because we can include those coefficients in front of the x squared term. And that's more universal. All we have to really do in order to solve these now is just identify what b, what a, and what c is. Okay, coming back up here, if we know what a, b, and c are, we plug these into our formula and we can solve any quadratic equation. Okay, and that's just kind of the proof of how you derive the quadratic formula from completing the square.